So let's spend few moments on three important equations that we study for gases. Ideal gas equation, which is also called a perfect gas, can be represented like this. P is the pressure and it is equal to RT divided by the molar volume, right? So that's the most beautiful equation. No molecular interactions, molecule sizes are completely gone. So that is the perfect gas, also called the ideal gas equation. Now, the most important real gas equation that we encounter in our studies is the van der Waal equations. So let's now see these, how it is different from this thing. There is a pressure correction, we all know that. So let us write P is equal to R T. Now this volume is no longer Vm, it has some decrement because of the molecular space, that is excluded volume. So you write it better like this, Vm minus B, and then there is a molecular correction due to attractive terms, minus A divided by Vm square. Here you do not put B. You put B only here because it is container volume you take. So this correction shows that this is the pressure of the gas if it is colliding with the wall decreased by the attractive force. That's what you measure through the barometer. And the third equation that is used for derivations, that is virial equation, it will look like a power series. So generally we express this like this: P is equal to RT divided by Vm. So this much is like perfect gas, and there is a bracket coming up starting with the first one, and there's a second virial coefficient. B depends on temperature, divided by, you have the same as Vm, and when this goes inside it will become Vm square, followed by the third virial coefficient C, which also depends on temperature, divided by Vm square. So like this. So this is the virial equation used to generally get the boil temperature. Now, what is the important case here? We actually go ahead with this equation and we try to convert it into a reduced form. You know what's the reduced form? For that, let me introduce you the critical parameters for the gas: PC, VC, and TC. So you know that PC is equal to A divided by 27 B square, VC is equal to 3B, and TC, you know, no guesses about that, 8A divided by 27 RB. That's amazing. Now, what you do, this equation is actually depending upon these two things. So in order to get rid of this A and B, and you would like to have a better representation so that the equation has a universal applicability, right? So that's called corresponding states. So we introduce some reduced parameters like this. P reduced is equal to the pressure of the gas divided by PC. Then similarly, V reduced and then T reduced. So when you do that, you get the van der Waal equation in reduced form, that is equal to P reduced is, here you get 8 T reduced divided by 3 V reduced minus 1. Then you have further minus 3 divided by V square. So one important thing, you have all the parameters here are dimensionless. So this is the equation of corresponding states, and you can really use this equation for the comparison of gases. So that's a brief revision of various gases equations which we use.